Hey y'all, we are Memphis Communiversity and we're back for another Calculus Done Wrong lesson where we run calculus before calculus wrongs us. And today what we're going to be doing is we're going to be starting a new lesson, a new unit, so that's pretty exciting. We're going to be starting our shape of curves unit, which is one of the most important units on the AP exam or college calculus exams. And basically what we're going to do is we're going to use calculus in order to determine the graph of functions. And I know what you're thinking, I wasn't very good at graphing functions in a previous math class. A lot of students aren't. But I have good news for you. You can still stay in the video because what we're going to do is we're going to use calculus to determine properties of these graphs without actually having to draw the graph itself. So what we're going to do is we're going to, in the future, in these next few videos, we're going to use the first derivative and the second derivative to determine various properties on our graph of f. But before we do that, that's actually not going to be for this video. That's going to be for the next 3 videos or so. For this video, we are going to be focusing on a tool called Sine Charts. So what are Sine Charts? Sine Charts are pretty similar to the graphs of f, but basically we only care about where the graph of f, whatever function we're dealing with, is positive or negative. We don't really care how tall it goes or whether it squiggles like this or this. That's why some teachers call it the squiggly line test, not actually a calculus topic. So basically what we're going to do is we're going to try to determine where these functions are positive or negative. That's why we don't have to be as precise as when we're drawing graphs of functions. We don't have to worry about amplitude. We don't need to worry about certain shifts and things like that, as long as we can place those zeros correctly and just see where it's positive or negative. So that's what we're going to do today. We are going to be doing Sine Charts. Keep in mind that some teachers teach the squiggly line test or Sine Charts by plugging in points in every single interval. But I don't know how to calculate anything, so I'm not going to do that. I'm going to try to draw my Sine Charts the same way every single time, where I'm probably not going to mess up as much because I'm not going to be plugging in numbers. And sometimes plugging in numbers is pretty cruel or pretty annoying. The numbers get kind of complicated. You might easily mess up, and then you mess up the Sine Chart. So in this case, what we're going to do is we're going to focus on just drawing the Sine Charts in a very general method. So let's get started. So first off, again, we are drawing Sine Charts today. This is going to be useful for us when we do the next 3 videos, when we draw Sine Charts of f prime and we draw Sine Charts of f double prime. But for now, we're just drawing Sine Charts of general functions. So it is called Sine Charts, S-I-G-N and not S-I-N-E, because again, we're focusing on the positive or negative sign of functions over various intervals. So the main things we're going to be talking about are mainly polynomials. So polynomials. Notice that polynomials are usually written in general as something like a to the n, x to the n plus a to the n minus 1, x to the n minus 1, all the way down to a squared x squared, and then like a1 x1 plus a0. So this is what is called a polynomial. You're very used to this by now, even if you don't know the general form. There's something like 3x to the 4th minus 2x cubed plus 7x minus 8x plus 1 or something like that. So when we draw these Sine Charts of these polynomials, the very first thing and perhaps the most important step is to factor the polynomial as much as possible. And you might have a different definition of what you consider factored, but I consider something factored if it's of the form x plus or minus something, x plus or minus something, x plus or minus something, maybe raised to different powers. So for example, I don't like it when it's like 8 minus x raised to the cube. I like it as x minus 8 raised to the cube. So we'll see how we deal with that. And I don't like pluses or minuses separating them because I'm not going to be able to draw the Sine Chart. I need it x plus or minus something, x plus or minus something, x plus or minus something. So always when I factor, I'm going to have some number in the front, and then I'm going to have x plus or minus some 0. We can call it C1 raised to some power n1. This is a little bit confusing in terms of notation, but this will eventually look like x minus 2 to the 5th, where 2 is C1 and then n1 would be to the 5th. This is called the multiplicity of the 0. So in this case, then we're just going to keep going. So we'll have the second 0, whatever. We'll have as many zeros as we need. I don't know how many zeros we'll have, so we'll just call it Cm. N to the m, but basically it's again going to be something of the form like we'll have a 3 in the front, and then we'll have x minus 2 to the 4th, and then the next term might be x to the 8th, and then the next term might be x times x minus 5 to the 7th or something like that. So we're just going to factor everything as much as possible, and again, that's going to be the key step where it's x plus or minus something, x plus or minus something, x plus or minus something, not something minus x. So once you factor it as much as possible, then all you have to do is determine two things. First thing we call end behavior. Basically, what does the sine chart look like towards the ends of the graph? That's why it's called end behavior. And then we have to talk about zero behavior, what happens at each of the zeros. So let's first talk about end behavior. So how are we going to determine end behavior? It's based off two things. First off, you have to factor everything as much as possible, and then you'll be able to gather these two things from the factored form. So the first thing is determining whether the number in the front is positive or negative. So are you dealing with a positive or negative polynomial? Another way to think about this is if you factor, if you have your original polynomial, what is the leading coefficient? Is it positive or negative? Again, it's going to be a very easy question if you're able to factor it just like this, because you'll just look at this number. If it's negative, it'll be negative. If it's positive, it'll be positive. The second thing you need to count is you need to count the total number of zeros. So count total number of zeros. And you're determining whether this is even or odd. I don't know why my B is so bad here, but I'm going to change it. But it's number of zeros, and you're determining whether this is even or odd. Another way to look at this is look at the original polynomial and what's the leading exponent. So for example, if we have like x minus 2 to the third, even though that looks like 1 0, that's actually 3 zeros because x minus 2 to the third is contributing 3 zeros because of the 2 to the 3. So what we're going to do is we're going to add these guys up, and that's going to be our total number of zeros. So I'm not just meaning the number of factors, but the number of total zeros, because certain factors can contribute multiple zeros if you're raised to an exponent. So once you have these two informations, there's only going to be 4 cases: positive even, positive odd, negative even, negative odd. So let's draw those pretty classic pictures. So positive even, what it's going to look like, so we can write positive even. Positive even. Well, positive even is just a parabola, regular parabola, starting from the top, ending at the top, as you go from left to right. So when I have my sine charts here, they're going to be number lines. It's going to start at the top, end at the top. I don't know what's going to happen in the middle because that's going to be zero behavior, but I do know that it's going to look like this. It's going to be a general parabola. Positive, negative, or not positive, negative. That's not just such a thing because you're either positive or negative. Let's do negative and even this time. So negative even is also pretty easy. Negative even is just an upside down parabola. So what you're going to do is you're going to draw a number line. I don't know what's going to be in the middle, but I do know that it's going to start at the bottom and end at the bottom. So it's going to start negative and end negative, where this one started positive and ended positive. Then we can have things like positive and, let's see if I can spell positive and odd. So that's going to start negative, and then as you go left to right, it's going to end up positive, just like positive slope lines or the function x cubed. So when we draw these number lines, we're going to start at the bottom, end at the top. Don't know what's going to happen in the middle, but I do know it's going to end up at this place. So that's why it's called end behavior, because we have this sine chart and we know the end behavior of the sine chart. Finally, positive, negative, or not positive, negative, I keep saying that. Negative, odd, the reverse of this one, the last choice. Again, it has to be one of these 4 choices because it exhausts the number of choices that we have. Negative odd is just a negative slope line, so it starts positive, ends negative, or a negative cubic function, and it's going to look like this. So this is going to be our end behavior. So that's what we're going to count first. We are going to determine end behavior, and then we will be ready to determine zero behavior once we fix end behavior. So anytime I draw these sine charts, I'm going to draw a number line. I'm going to draw one of these 4 pictures. I'm going to determine them by these 2 questions, and then we'll be ready for zero behavior. So let's talk about zero behavior, and then we can draw our sine charts. So zero behavior is what happens in the middle of the end behavior. It's pretty easy. It's similar to what we just drew. So zero behavior is dependent on each of the zeros. So basically what's going to happen is we are going to come to a number, like let's call this C1, and we're going to call this C2. So what's going to happen is we're going to come to this number, and it's going to be dependent on the end behavior. And as we come to this number, what we're going to do is we're going to go through if the multiplicity is odd. So it's going to be N1 is odd. So again, what we're going to do is we're going to come to a 0, If I look at the multiplicity or the exponent of that factor, and if it's odd, like x plus 1 to the 1, or x plus 1 to the cube, or x plus 1 to the 5, then we're just going to cross through, boom, straight through the number line, and that's going to be it. Then, as we approach things that are positive, if we look at this 0 and we say, oh, not positive, even, I keep confusing even and odd, positive, or negative for some reason. So if we come to this 0 right here, let's call this C2, and suppose this were even, and 2 is even. For example, if this were x minus 3 to the squared, an even power, or x minus 3 to the fourth, an even power, what we're going to do is we're going to bounce like a parabola, and it's just going to bounce. So again, 0 behavior is pretty easy. If your multiplicity is odd, you're going to cross through the number line or cross through the sign chart. And if you're even, you're going to bounce at that 0. Bouncy, 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 bouncy. So again, either cross through or bounce, and you just look at the exponent of that factor. This might be really, really confusing, so I feel like if we do some examples, you should be good to go. So let's do some examples. Hopefully you've written down how to do this. Again, really 3 steps. We're going to factor everything as much as possible. We're going to determine end behavior by counting up the number of zeros and looking whether this is positive or negative. Then we're going to do 0 behavior, either bouncing or going through at every single 0. So let's see how this works. So I'm going to erase this. I'm going to erase, and let's do a few questions. So let's start off with something already factored. Sorry, my board is a little smudgy, but sometimes that's what happens when you're doing a lot of math, and it's always fun to do a lot of math. So let's start off with this sine chart. Let's draw a sine chart of this function right here. So we're going to do negative 8. Then we're going to have, let's say, x minus 1 cubed, x plus 2 to the second, and then let's have x minus 5 to the third. So this is going to be my polynomial. Notice that it is factored the way I like it. A number in the front, and then x plus or minus something to a power, x plus or minus something to a power, x plus or minus something to a power. No something minus x's, so this is not 1 minus x. If it were 1 minus x, I would have to deal with it. So this is factored as much as possible. Now we're ready for end behavior. So let's find the end behavior. So we can write end behavior. We don't even need to write end behavior. Let's just write positive or odd. Positive. I keep confusing these. I don't know why. Positive or negative. So we'll determine that. And then we'll determine even or odd. So this is going to be the end behavior. We might as well write end, even though I didn't want to. But end behavior. So first off, positive or odd is an easy question, especially if you factor it as precisely as possible. So notice that this is negative 8. Because we factored as much as possible, it looks like we have something negative. Then we're going to determine even or odd. But don't count it based off 1, 2, 3. Count it, remember, because we have to consider the multiplicity of each of these guys. So let me count it for you. Negative 8 does not contribute any zeros because there's no x's in the front. So it's going to be 1, 2, 3 from this guy, 4, 5 because of the 2, and then 6, 7, 8. Another 3 from this guy right here. So it's 3 plus 2 plus 3. That's 6 plus 2 is 8. So it looks like we're dealing with n is equal to 8. That's going to be the leading exponent of our polynomial if we were to factor all of this out. So it looks like we have something even here. So then what you do is you just draw a number line. So this is going to be the beginning of my sine chart. How exciting. What you first need to do is plot the zeros. So we're going to plot the zeros pretty easily. Keeping in mind that when you plot these zeros, you have to plot them in the correct order. It should be pretty easy to know what the zeros are. It looks like we have x is equal to 1, x is equal to negative 2, and x is equal to 5, if you can tell that this is a 5. Maybe I should make it a little bit more clear. 5. Again, the negative 8 does not contribute any zeros. So we have 1, negative 2, 5. We do want to position them in the right order because it's a number line. So it's going to be negative 2, 1, and 5. So now we're ready for end behavior. Because we determined earlier that we have an even negative thing, that means that it's going to be an upside down parabola. Remember our 4 possibilities. So this is even and negative. Upside down parabola, that means it's going to start over here and it's going to end over here. That's what upside down parabolas end. Now we are ready for 0 behavior because we determined the end behavior. So how I like to do this is I like to start on the left because we usually go left to right. And then as I approach the 0, I look at the factor that corresponds to that 0. And again, if it's even, it bounces. If it's odd, it goes straight through. So in this case, as I'm approaching negative 2, notice that it's this factor that right here that it corresponds to. This is raised to the 2. 2 is even, so it looks like it's going to perform a nice little bounce. So bounce. Then as I approach 1, I look at that factor. This is raised to the 3. So because this is raised to the 3, that's an odd number. So that means it's going to go straight through here. Finally, I am going towards this number 5. As I approach the number 5, it's odd, and not the 5, but it's the 3 that counts, the multiplicity of the factor. So because this is a 3, that means it's odd. It will go straight through. So it's going to go straight through this 0 right here. And notice, just a very lovely thing, it ends up where I want it to end up. I wanted it to look like an upside down parabola. And notice it does look like an upside down parabola towards the ends. If I ended up over here, then I would know that I probably messed it up somewhere. So this is going to be the sine chart. Remember, we don't care about this actual graph. Mine isn't very pretty. Hopefully yours is a little bit better. What we actually care about is negatives and positives. So while we have this nice squiggly line here, we didn't plug in any points into the sky because that would have been annoying. What we're going to do is we are going to label each of these intervals as negative or positive. So notice on this first interval, from negative infinity to negative 2, this is negative. From this interval right here, negative 2 to 1, it's underneath the x-axis or this number line, so it's negative as well. And from here to here, this is our only positive piece, 1 to 5, because it's above the x-axis. And finally, from 5 onwards, it's going to be negative. So the actual sine chart, what we're going to focus on in later videos, actually isn't this line itself. It's just this negative, negative, positive, negative. And that's how you draw sine charts in this basic example. Let's go for harder stuff. So I'm going to erase this. Hopefully you pause the video if you need to, but I'm going to erase this and we're going to do another one. So let's do f of x equals 3 times e to the minus x. So let's make it a little bit trickier. And then we'll have something like, I want x minus plus x squared. And we're going to raise these to these, and then we're going to put a 4 here. So this is going to be my guy. I'm going to put a minus actually. So this is my polynomial. It looks a little bit more complicated than the previous one. First off, we have this e, but we're going to deal with that later. The thing that is actually giving me a little bit of a pain right now is that this is not factored. The previous one was factored as much as possible, but this is not factored as much as possible. Again, because it's not x plus or minus something, x plus or minus something, x plus or minus something. So what I'm going to do is I'm going to do a few algebra steps. I'm going to rewrite this because I don't know what to do with this, and I'll deal with this later. Then I'm going to take out as much as I can because then that's how you factor. It looks like I can take out an x squared. And then we're going to have left, it's going to be 1 minus 4x. And then finally, this is x minus 1 squared. So this is not of my form still. I think I want to do one more step because again, I don't like it of the form something minus x. I like it x minus something. So if you don't know, if you have this smiley face and you subtract it from this frowny face, and if you wanted to switch it around, because sometimes you want to switch it around, that's just negative, and then you can just switch it around. So it's going to be the frowny face minus the smiley face. So another way to say this, if you have x minus y, that's equal to negative y minus x. So again, I like it always of the form x minus something. So what I'm going to do is I'm going to write this as 4x minus 1 instead. But you can't just change things arbitrarily as you want. So what's going to happen is we're going to have to take a negative out because again, negative x minus y is the same thing as y minus x. So there's going to be a negative in front of this 3. And then we're going to factor it like this. So actually, this is the most factoring I can do. So let me talk about this e to the minus x, because that's the thing that's the most annoying thing, or actually the thing that's causing me the most confusion right now. So keep in mind that again, throughout this video, we are not drawing the graph of functions, we're only drawing sine charts. So what we want to do is determine whether things are positive or negative. So I'm going to first talk about this 3. Notice that if you have the number 3, and if you have a positive thing and you multiply it by 3, you're going to remain positive. And if you have a negative thing and you multiply by 3, for example, negative 4 multiplied by 3, what you're going to end up is a negative thing, negative 12. And that's because 3 is positive. If you multiply something by a positive number, its sign is going to remain the same. So a positive thing times a positive thing is still positive. If you originally start off with a negative thing, multiply it by a positive thing, you'll end up with a negative thing. So if you don't know, e to the minus x is also always positive. E to any power, even a negative power, is positive because it's the same thing as 1 over e to that thing. If you don't know, e's graph looks like this. It always remains above the x-axis, even on the negative side. So what we can do is we can make this sine chart of f of x a lot easier. Or what we can do is we can view this sine chart of f of x as the sine chart of a different function, basically by ignoring anything that is always positive, because again, positive things do not affect the sine chart. So what you can do is you can really just not look at this 3, because the 3 multiplying by the 3 will not affect the sine chart. Certainly the negative will, but not the 3, because the negative affects negative and positiveness, but multiplying by 3 again doesn't affect negative or positive. And the same thing is true with this e to the minus x. I can basically just ignore it because when I draw this sine chart, e's are not going to affect the intervals, the sign of the intervals, the positive and negative, the positiveness or the negativeness of the sign. Sorry, I can't talk. It will certainly affect the graph, but remember, we're not drawing graphs, we're drawing sine charts. So we're actually ready to draw the sine chart from this guy right here. So let's plot the zeros. So it looks like this x squared equals 0. Don't forget this guy. This corresponds to the 0 of 0 itself. So this is going to be x is equal to 0. If you need to, if you have these weird kind of lines, if you want, you can set this to be equal to 0 to solve. So this one is going to correspond to 1, 4, for example. And finally, this one is x is equal to 1. So now we are ready to draw the sine chart. Let me lower it a bit so it doesn't interfere with our stuff. Again, what you need to do is plot the numbers in order. That's going to be 0, 1/4, and 1. Then we have to decide, is this even or odd, positive or negative? So again, we ignored all this stuff because it's positive, but because we factored as much as possible, all we have to do is just look at it and see if there's a negative in front. There is. So this is going to be negative. Then we have to count the number of zeros, but again, we're just counting one by one. So it's going to be 1, 2, 3, 4, 5. Again, you're just looking at the exponent. So it's 1, 2. This is technically to the 1. So it's 1, 2, 3. And then finally 2 more, 4, 5. So it looks like we have n is equal to 5, which is going to be odd. So odd negative things. What's the end behavior of those functions? Well, it's going to start right here, and it's going to end right here. And that's going to be the end behavior. So now all we need is the zero behavior. So for the zero behavior, what we're going to do is, again, we're going to slowly approach a 0. As we approach the 0, we look at the exponent of the factor corresponding to that 0. So for example, in this case, as we approach x is equal to 0, we're looking at 2. 2 is even, so we bounce. So we're going to bounce right here. Then we go to 4x minus 1. But 4x minus 1, that is to the 1, so that's odd, so it's going to go through nicely like that. Finally, as we approach x minus 1, that's x is equal to 1. As we approach, because this is to the 2, it's going to bounce. So this is my sine chart. Again, negative and odd makes it go right here and here after we ignore the 3 and the e to the minus x. Negative and then 1, 2, 3, 4, 5. Then as we approach these zeros, we bounced here, we went through, we went through. Let's draw the sine chart actually. Again, we don't really care about what this actually looks like. We only care about positive or negatives. Looks like it's positive in the first 2 intervals, negative in the second one, and negative in the third one, and negative in the fourth one. So that's how you draw sine charts. Nothing too crazy. I'm explaining it a little bit more than it actually has to be explained. These questions aren't actually that bad. Again, what you do is you factor as much as possible. If you can also ignore anything that's positive, for example, anything with e to a power, also positive numbers. Then plot your zeros, count the number of zeros, determine if you are a negative or a positive, and then that would determine end behavior. And then zero behavior is pretty easy. Just look at each of the zeros exponent, and then if it's even, it'll bounce, and if it's odd, it'll go through. So let's practice a few more of these because we want to sort of carry about all the scenarios that might happen. So I'm going to erase this. I'm going to erase this guy. Let's do something a little bit trickier. So let's do, again, it's very, very smudgy, but I don't know if I can do anything about it. Hopefully you can see this. Let's do 4 times x minus 2 to the third, x plus 1 squared. Then we're going to do plus 2 times x minus 2 to the squared, x plus 1 to the cubed. So again, when you look at this thing, what some of my students mess up is that they'll immediately draw the sine chart because they're so excited to draw sine charts. I can understand the urge, but again, the main hint that we have, the main sort of tool that we have, the main warning that we have is to factor everything as much as possible. Because of this plus right here, I don't consider this factored as much as possible. Let me draw a better arrow. Because it's not of the form something times x minus something, x minus something, x minus something. It's x plus or minus something, x plus or minus something, plus and a totally new thing. So what we need to do is factor as much as possible. In these questions, the way to do this is to factor out as much as possible, and then you'll be left with the thing that is factored as much as possible. So what I'm going to do is I'm going to do a bunch of algebra steps so that I can get to the form where I can draw the sine chart, the thing factored as much as possible. So first off, it looks like I need to take out a 2. So I'm going to try to factor out as much as I can. So notice that there's going to be a 2 in common. And then also, both of these things share x minus 2's. So let's see how many x minus 2's do they share. Well, it looks like this one has 3 and this one has 2. So they share 2 x minus 2's, x minus 2. Then we look at how many x plus 1's do both of these share. Well, it looks like it's going to be 2 x plus 1's as well, because this has 2 x plus 1's, this has 3 x plus 1. So what do they have in common? Well, even though this guy has one more x plus 1, they both have in common 2 x plus 1's. So it's going to be x plus 1 squared. So we're going to factor this out of both of these guys right here. So there's going to be something remaining. If we factor all of this out of this, what's remaining? Well, there's still going to be a 2, because 2 times 2 is 4. And then also we took out all the x plus 1 squared. So it looks like what's going to be remaining is going to be a final x minus 2. So we have that. Then we're going to write a plus here. That's this plus right here. And then we're going to see how much remains out of this second term once we factored out all of this nice little stuff. So we factored out the 2, we factored out the x minus 2 squared, we factored out 2x plus 1, so it looks like there's going to be one final x plus 1 remaining. So that's pretty nice. But keep in mind that I'm still not ready to draw the sine chart because of this bracket term. I'm going to simplify as much as possible. It looks like it's not going to be bad to simplify. So let's rewrite this. 2x minus 2 squared, x plus 1 squared. And then we're going to have, just factoring a little bit, it's going to be 2x minus 4 plus x plus 1. Still not factored as much as possible. I can still simplify this, so let's not be lazy. Let's just keep writing. Let's just keep chugging along until we get something as factored as much as possible. I like factoring steps because it's not too bad. There's no calculus involved. 2x plus x is going to be 3x, and then minus 4 plus 1 is going to be minus 3. One last thing, it looks like we can take out a 3, so we might as well do that. So we're going to take out a 3. So we're going to take out a 3, this becomes 6, and then this is going to be x minus 1. And finally, we have something factored as much as possible, so now we're ready to draw the sine chart. Again, all of these steps were just to get to this step right here. X plus or minus something, x plus or minus something, x plus or minus something. Not separated by this little pesky plus. So now we're ready to draw the sine chart. All of these steps are to get to the factored form, and you can only draw the sine chart when you have the factored form. So let's get going with this one. So this one right here, how are we going to do this? Well, now we're ready for the question. First, let's ask, is this even or odd, positive or negative? So even or odd, positive or negative. Keep in mind that this 6 is positive. We don't actually care about the 6 itself. It's not negative 6. So this is going to be positive. And again, we can answer these questions because we factored everything as much as possible. Then we have 1, 2, 3, 4, 5. So it looks like we're dealing with an odd thing because n is equal to 5. So now we're ready to draw our number line. What are our zeros? Well, it looks like it's negative 1, 1, and 2 in that order. Negative 1, 1, and 2. What does positive and odd look like? Well, it looks like this, starting at the bottom, going through the top. So in this case, it's going to be positive and odd starting right here, ending right here. So now we're ready for zero behavior. As we approach negative 1, we look at the factor corresponding to negative 1. That's this guy right here. Be careful, it's not this one, it's this one, because this is the thing that makes this 0. So when we plug in negative 1, because this is a 2, we're going to bounce there. So we're going to bounce quite nicely like this. Then as we approach 1, notice this is technically to the 1, so it's going to go straight through because it's an odd multiplicity. So we're going to cross through. And then finally, as we're approaching this last 0, that corresponds to this guy right here. Its exponent is even, so we're going to bounce again. One little bounce, bouncy bounce. And notice, so beautifully, we end up where we're supposed to end up because positive odd tells me I need to start negative, end positive. So this is the sine chart. Again, the most difficult part was by far doing all of this factoring. Let's draw the negative or positives. Looks like it's negative in this, positive, and then positive. So that's how you draw sine charts of functions. Again, nothing too crazy, hopefully. You can see that it's the same thing over and over again. If you can get it to that factored form, count, fix the end behaviors, do a little bouncing action or going through based off the exponents of each of the factors. So for now, what I'm going to do is I'm going to draw fractions because sometimes students are confused with fractions. But what we're going to see is that they're actually the same exact thing as all the other ones. So I'm going to erase this. So let's erase this. I'm going to erase a little bit more. Let's erase this a little bit more. Let's have the fraction something like x squared minus 4, nothing too crazy. And let's have 8 minus x. So we're going to try to draw the sine chart of this fraction right here. The great thing, the best thing in the world is that we're not drawing the graph of these functions, which this graph would be quite intimidating with asymptotes and things like that. All we care about are the signs. So when we draw these sine charts, what we're going to do is we're just going to factor the numerator as much as possible. We're going to factor the denominator as much as possible. Then we're just going to consider as if it wasn't a fraction. We're going to draw all the zeros, ask our normal questions about even or odd, positive or negative, do zero behavior the same way, and we're going to be good to go. So basically, fractions are nothing new. So first off, the key step by far is to factor as much as possible. Let's factor the bottom here, x squared minus 4. It's going to be x minus 2 times x plus 2. Difference of squares, of course. But this is the thing that's giving me the most headache because it's not x minus something, it's something minus x. So again, I want to switch it around. So I'm going to write it as x minus 8. But you can't just switch things arbitrarily. So that means that there's going to be a negative in front. And this negative is very key when we ask ourselves the question positive or negative. So what do we do next? Well, because this is factored as much as possible, now we can answer the question positive or negative. So because we have this negative thing, we're going to have a negative thing. So it's going to be negative. And then we're going to count our zeros. Looks like none of these are actually to powers other than 1. So they all contribute just 1 0. So it's going to be 1, 2, 3. So I'm not going to complain about that. It's going to be n is equal to 3. That means it's odd. Again, now we draw the sine chart, but the sine chart isn't any different than without a fraction. Just put every single 0 that you see onto the sine chart. Looks like we're going to have negative 2, 2, and 8 in that order. And again, once you don't even need to look at this anymore, unless you want to have the numbers. You actually do have to look at this, but you don't have to think about it as a fraction. If you want, you can think of this as negative x minus 8 times x minus 2 times x plus 2. Again, we're not drawing graphs, we're drawing sine charts, and because these are divided by, well, that's not going to affect the sign because divided by -1 and multiplied by -1 gives you the same sign. So in this case, negative and odd looks like a negative slope line. It's going to start here and here. And then what's going to happen is because all of these are to the 1, those are odd powers. So we're going to go through on all of them. So we're going to go through violently, go through and go through. So that's what it's going to be. Notice that we end up where end behavior expects us to end up. So that's always great. Let's draw some positive or negatives. Positive, negative, positive, and negative. So it was negative and odd. So that means it started here, ended here, and crossed through on each one because they're all to the 1. And we just had a great time. So that's that one. Again, nothing too crazy. Let me try to do another fraction for you, just as a way to make sure that we are understanding this. So I'm going to erase this. I'm going to erase this. Let's do something a little bit harder. Let's do something like 25 minus 1 over x. So this is going to be my next thing. And do I want 25 minus 1 over x? I think I actually want 25x squared. 25 minus 1 over x squared. So we're going to factor this. So we're going to try to draw the sine chart of this, but just like in the previous examples, when you want to draw the sine chart, you need it to be the simplest form possible. So basically, this is something minus a fraction, but what we're going to try to do is make this one single fraction. I actually don't think we want this one. Sorry about the problem here, we actually want 1 minus 25. So now that we have the actual thing that we want, let's go for it. So again, this is the thing I want to find. Sorry about that mistake. But this is the thing I'm going to start off with. But again, what we need to do is we need to simplify this as much as possible. Instead of having this fraction minus 1, what we're going to do is we're going to try to combine this into one single fraction. Then we're going to be able to factor both the top and the bottom, the numerator and the denominator, and we'll be able to draw a sine chart. So how do you combine these together? Well, what you need to do is you need to have a common denominator. What's going to be the common denominator? Well, it's going to be x squared because they're subtracting from 1. So it's going to be x squared over x squared minus 25 over x squared. And again, the point I'm doing this, why I'm doing this, is so that I can try to combine these. So in this case, it's going to be x squared. Hopefully my pen doesn't die before the end of this video. I can combine this into one single fraction, x squared minus 25 over x squared. So now what I can do is I can factor everything as much as possible. Looks like my denominator is factored as much as possible, so all I have to worry about is my numerator. Well, x squared minus 25 is x minus 5 times x plus 5. And it looks like we are ready to draw our sine chart because we have everything factored as much as possible. Even if we have a fraction, we're not intimidated by fractions. We just draw the sine chart in the same way. So let's ask our normal questions. Is this odd or, let's do positive or negative first. So because there's no negative in the front and we did factor as much as possible, this is going to be a positive thing. So this is positive. Then we have to ask, is this odd or negative? Keep in mind, again, this squared contributes 2 zeros, so you might think this is 3 and odd, but that's wrong. It's 1 0, 2 zeros, 3, 4 zeros, so it's going to be n is equal to 4, which means it's even. So it looks like we're having something that looks like a parabola as its end behavior. Let's draw the zeros. So it looks like this one corresponds to negative 5, then it's going to be this 0, x squared equaling 0 corresponds to the 0, 0, then we have 5. So then we have a positive even thing. Again, that's a parabola, so it starts right here, ends right here, and now we're ready for end behavior. This is technically to the 1, so as I approach this negative 5, that's actually this term right here, but it's still to the 1, so it's going to go through. Then as I approach 0, because it's squared, that's an even number. The power is even, not the 0 itself, but the power is even, so that means it's going to bounce here. And then finally, as it goes to 5, I'm not looking at this 5, I'm looking at this invisible to the 1. Again, to the 1 is an odd power, so it's going to go straight through. So it's going to be this guy right here. And this is the sine chart. Let's label positive and negatives. Positive, negative, negative, positive. So that's it. Those are going to be our sine charts. What we did is we did sine charts of both polynomials and fractions. We had e to the x's, and we saw that we could ignore them. We saw that fractions weren't any more difficult than any other sine charts. All we did was we factored, we determined end behavior, positive or negative, odd or even, and then we determine zero behavior. Do we bounce or do we go through at each of the zeros by looking at the power of the factor? There's just one small thing in that sometimes you're not going to be able to do this process because the function is too complicated where it goes even or odd, positive or negative too many times. So that's going to be really your trig functions. What I recommend is that my students just memorize general trig function graphs. Use the graph of trig in order to draw a sine chart. So I'm going to draw the 4 basic sine charts for trig. It's going to be sine of x, negative sine of x. Each of these are going to be on the interval of 0 to 2 pi. So keep in mind that sometimes the interval is a little bit different. I usually at least ask my students to remember this amount of trig, negative cosine of x. So I'm going to quickly draw these. Again, I can't ask even or odd or positive or negative because I'm dealing with sine of x and not a polynomial, or even a fraction of polynomials. So in this case, just know the graphs. This is 0 to 2 pi. Keep in mind that this goes on forever. All sine and cosines, they're just waves and they go back and forth. So that's why they like to fix an interval. So we're going to fix an interval. And then 0 to 2 pi, well, sine starts at the origin and it'll cross at pi. And it'll go up first and then down first, if I can cross with the right thing. And it's positive and negative. From 0 to pi, it's positive. From pi to 2 pi, it's negative. I don't actually care about how tall this is. So if this were 5 sine of x, I would draw the same picture. I never label the amplitude because we're drawing sine charts. What is negative sine of x? The sine chart, S-I-G-N, chart of negative sine of x. Well, this is just the upside down version of the previous one. So it's going to be this, where this crosses at pi, 2 pi, and this is 0. So this is negative and positive. I don't actually care about the wave. I care about the negative or positive, blah, 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 blah. Cosine, it looks a little bit different. It starts right here, crosses and crosses. So it starts at pi over 2 and 3 pi over 2. If you want it, it continues to go, of course, over here, but we're fixing everything on 0 to 2 pi. So it looks like it's going to be positive, negative, and positive from 0 to 2 pi. We should label some points. 0 and 2 pi. So from 0 to pi over 2, it's positive. From pi over 2 to 3 pi over 2, it's negative. And from 3 pi over 2 to 2 pi, it's positive. Finally, negative cosine is the upside down version of this. So it's going to look like this, where this is pi over 2, and this is still 3 pi over 2. So it's going to be the flip. It's going to be negative, positive, and negative on these intervals, where we stop at 2 pi because that's what they asked us to do. Sometimes they'll go from negative pi to pi. Sometimes they'll go for something weird like negative pi over 2 to pi over 2. Whatever you do, just know these basic sine and cosine graphs. And if it gets even more complicated than that, if it's like sine of 2x, for example, or cosine of negative 3x, something like that, what you want to do is you want to factor the zeros and perhaps actually do what other teachers recommend. Plug a number inside the interval. If you plug that interval point into the cosine of x, and you see if it's positive or negative. So for example, if we were doing this simple one, if you don't know what these pictures are, I would plug in, for example, pi over 4, because pi over 4 is within the interval of 0 to pi over 2. I would find cosine of pi over 4. I don't actually care about the number, even if it's root 2 over 2. All I care about is whether it's positive, so then I would draw a positive there, if you don't want to draw the graphs. But hopefully you see that other than trig, our method is going to be pretty useful. You can use it for every single sine chart of polynomials, even if it includes some e to the x's multiplied, even if it has some weird multiplicity things, if you're able to factor it as much as possible. And again, even if it's a fraction. Sine charts are so important. Again, we're going to be using them in the next 3 videos. So if you want more practice with this, of course, we have a Girls Teach Calculus video in the description of this video, where if you watch that video, in that video, one of my former students practices a lot of sine charts where she goes through this method for a lot more questions, basic polynomials you have to factor, things with e to the x's, fractions, and finally some annoying trig ones. So be on the lookout for that. Check that out if you want more practice. And hopefully you'll stick with us as we continue our Shape of Curve playlist, where we actually do calculus, where we actually find derivatives and second derivatives. Again, in our next video, we're going to be drawing sine charts of f prime. In the video after that, we're going to do sine charts of f double prime. And the video after that, we're going to come back to sine charts of f prime. But consistently throughout this video, what we're going to be doing is we're going to be doing sine charts. So we're going to be determining end behavior. We're going to be determining zero behavior. Can't talk at the end. But until then, thanks again for watching just like normal. And I hope to see you in our next video. F is increasing or decreasing, which will feature these sine charts as we draw sine charts of f prime. Thanks again for watching.